Super fascinating. Thank you. Yeah, we started off told my parents I was not going to place once a month now. And the only there's a good reason. I made it. She was out here. Yeah. Yes, I can do that. Like, and so we ended up there. So, 3.5 months. All right, guys, get some beer. We're going to get started in 1 minute or so.
I know we don't have time. I wanted to just check in with you, see how you were doing and all that sort of thing.
It's been a wild fucking ride this summer.
Okay, that's
so we should chat.
Yeah, it's okay. Let's do that. Maybe coffee or something like that. Or,
that sounds perfect.
Okay, maybe
yeah.
Let's see if I got any chance at the end.
Okay.
Yeah.
Where's my friend?
I'm right here.
I was talking. Okay.
Is everybody hydrated with non-hydrating liquid? Yes. Welcome to Analyze Boulder. So thank you very, very much for being here, spending an August evening with us. It's freaking gorgeous outside, but we're going to have an awesome time in here. Free beer and great talks and nerds all around. So yay, thank you. None of this happens without the organizing team, and so I'm Tony. This is Greg and Eric. Jen Wilson is our newest member of the team. Any of you guys that sign up to give a talk, you're going to be hearing from her. She's taking over a lot of Jennifer's duties, so luckily we won't ever forget her name. And lastly, our new addition is Patty, so stand up and wave. Miss Patty is going to be our our social media expert taking pictures, and I stand here in solidarity with Patty and congratulate her on being pregnant.
And Josh.
And Josh. Josh, stand up and wave. Happy daddy. Awesome. Also, a huge thank you to Galvanize. If you've been a regular here, you know that we've bounced and bounced and bounced to different locations because we kept growing. But Galvanize has become our home now for many, many years. So sign up for their mailing list. If you're interested in being a data scientist, they have a boot camp, find out about it, and just say thanks for letting us be here. So here's what's going on tonight. We have Sean Costello doing what I'm calling the Bracket Buster Cluster, but he'll explain more what that is. And then we have our regular Stephen Coleman, and I called it Scraping NHL Got Equipment. And lastly, we have Aaron Desmond. I called it DJ Data in the house, because that's the kind of mood that I was in when I wrote this. All right, but first off, we do have beer. It is free, but please make a donation because we pretty much pay for it and are scraping by each and every time. So thank you to the people that have put 20s in there, and I know that's happened a lot in the past. I heard last time that there was a competition to see which pitcher is going to have more money in it. Is that going on again?
Sure.
This month? There were a couple of so far it's pretty even.
I will count it at the end of the night and see who wins. No, you just handed me a sweaty lot of money. I did. Maybe it was Justin.
It was probably Justin. So anyone that's new, take a picture of this slide. We stay in touch throughout the month. We meet once a month here, but keep in touch with news and jobs and all sorts of cool, fun stuff. So get on the Slack channel, join the LinkedIn channel, and by all means, tweet. Can't just have Patty be the only one tweeting. It's just not cool. More pictures right now. Okay, so here's my favorite part of the evening. Who's got events going on? Who can share with me some announcements of other cool stuff that's going on? Other meetups, conferences, workshops.
Boulder Open Coffee on Tuesday.
All right, I'm gonna let you announce it.
Boulder Open Coffee Club will be Salinas, we're up front, every Tuesday, so next Tuesday at 8 a.m.
What do you guys talk about?
All things startup, revenue.
All things startup? Love it, sweet. Here's another announcement.
Hey guys, I'm Sagi. I'm going to be organizing a Denver startup week event called the State of the Denver Data Science Community. So please sign up for it. It's on Monday, September the 24th at noon. I'm also looking for folks who know someone or maybe they're doing some really cool stuff in data science. So please come up to me after the talks and I want to hear about all your cool data science applications. Thank you.
What else? Who's working on a project or wish they were working on a project and wants a collaborator?
I've got a project I'm working on.
How's that for timing?
I'm looking for people to interview, and I'm looking for a special kind of person. These are managers involved with analytical systems, usually in a more of a medium to large organization, and they're looking at neural networks, new technology to bring in. And I would like to conduct a short interview with these people. And trying to locate these is a little difficult. And by manager, I mean somebody who's tech savvy, but is not necessarily a data science PhD and has the technical knowledge about neural. So if you know such an individual, or if you are such an individual, I got the information right here about the interviews, some of the questions that I'd like to discuss with you. And this will go into a series of articles that I'm doing for data science. So, and I can do the interviews anonymously, so you don't necessarily need to use your name. So Richard Hackathorn, and see me afterwards, and I have some information for you. I've also posted it up on Slack and our meeting.
Thanks, Richard. Going once. Going twice.
Hi everyone, my name is Alex. I'm the CEO of a new sales intelligence startup called Signal HQ. If any of you are interested in learning about Looker or Google BigQuery on the Google Cloud Platform, have skills with Python, R, D3JS, or anything like that, talk to me. I'd love to get involved in more project.
Alex, it sounds like we need another pitcher for D3. Is that what I'm hearing? All right, we're gonna move on to jobs. Who is looking for a job? And if your boss is here, don't raise your hand. What are you looking for? Let's bring the mic over to you.
Hi, my name is Patrick. Brand new in town, just got to Colorado 2-3 weeks ago, so awesome to meet everyone here. I am just another web developer, quote unquote. So check out my website, ptrck.io. That's Patrick. That's my name minus the vowels. And love to hear from anyone who's looking for more web developers. So thank you.
Sweet. Who else? Who's hiring as well?
Hi, my name is Angela Luca. I work for Panasonic Automotive out by DIA. I work on the connected vehicles team, and I just found out a few hours ago that we are going to be hiring probably another data scientist, maybe data engineer, I'm not sure. It's a very, very cool project because we have a contract with the Colorado Department of Transportation to outfit a 90-mile segment of I-70 from Boulder to Vail with all these towers that can collect data from your car. Basically, your car is a big computer that's got all this data, like which weapons on your airbags and all this stuff. So there's so much data to work with there that we can. The goal is to be able to improve traffic warnings ahead of time, inclement weather ahead of time. It's like really cutting edge, and it's a super amazing project. So if you're interested, let's exchange contact information afterwards, because it's not actually been posted yet. If you want a notification, then I'm happy to send that.
Angela, you know this is live.
I have offered to drive I-70, to test, the roadside units, it might take 8 hours, while I take a ski detour, but.
Gotta get that per diem hotel in Vail.
I have one. Where I work in downtown Denver, I'm a product manager there. Our highest priority, although we do have a lot of jobs on LinkedIn for VF Financial, our highest priority is a senior mobile engineer or a mobile engineer. So you gotta have experience. You can't take someone fresh out of the boot camp, but if you have experience in things like Angular, if you have experience in Ionic, React Native, know someone that is going to talk to me. If you are referring me someone and they get hired, I will give you 10%.
He gets $1 million.
Any other job announcements?
Hello, Patrick. My name is Bing, and I work for a company called Mojo Technical Consultancy here in town. I work with full stack developers. I'm more experienced in the spectrum, and we're also looking for one designer as well. So we'll be expanding.
Awesome.
Hi, my name is Andrew. I work for a company called TrueU here in town. We work on Pearl Station, a few blocks away. We are looking for actually 2 data scientists. One definitely more senior, one a little bit less senior than that. We've got some really interesting problems working on kind of identification of people through how they walk, using accelerometers and gyroscopes on a phone, and various other kind of ways of doing that. We're looking to try to replace passwords. It's come talk to me if you have any interest or you want to know a little bit more. More than happy to connect. Here.
Great, thanks, Andrew. All right, I just want to go ahead and make an announcement for an event that I am co-hosting. It's an evening with women in tech. It is at Twitter on August 16th. That is a Thursday. So go ahead and sign up either on the Hexagon UX website or meetup site, or on the Twitter developer meetup site, or just come talk to me. All right, without further ado, we are ready for John.
Yeah!
It doesn't matter if I'm on the recording well. But Sean, we're gonna make you sound awesome.
Is this got it? I don't think I hear anything on the speaker.
No, you still have to talk.
Oh, it's just recording.
Yeah.
Oh, okay, it's just for the internet.
Yeah.
All right, finally I get to do this for some sports fans. It's gonna be nice. So you guys know, each year 70 million brackets are filled out for each March Madness. There's no doubt having some skin in the game makes it a lot more interesting. But you know, as fun as fantasy sports can be, there are still some downsides. Ladies, I'm sure you know some of these guys. Do you have any guy friends that just never shut up about fantasy sports? And guys, don't you hate it when you lose to your girlfriend's friend who just picks teams based on whoever has the hottest guys? Hello. Well, welcome the Bracket Buster, the solution to all your March Madness problems. I'm Sean Costello, a data scientist with a background in engineering and analytics in the energy sector, and I'm here to talk to you about the Bracket Buster. It's a machine learning model that uses gradient boosted classification and k-means clustering to predict March Madness winners. So this project was a feat in data aggregation and feature engineering. All the data, which are game logs and player statistics, was pulled from sportsreference.com, and that was used to engineer all the features used in the model, from win percentage, strength of schedule, team experience, points per game, and some experimental team composition features. So k-means clustering is an algorithm used to find natural groupings in data. In this case, I was trying to find player archetypes and break down the three core positions into various subgroups to further differentiate players who maybe play the same position but don't have very similar play styles. Like you could imagine some centers who can fly and dunk and shoot threes, and some others are just trees who stand in the paint and scrape rebounds. So I wanted to treat them as different people. So I broke down centers, forwards, and guards into 3, 3, and 4 subgroups respectively, expanding those 3 positions into 10 player archetypes. And the goal here is that maybe we can find some composition of that team that just is better suited to take on another team, improving our predictive power. So those player archetypes were normalized over the total minutes played to create the team composition features. When you look at this plot here, you can see that guards are represented in shades of blue, forwards in shades of orange, and centers in shades of green. You kind of see how the teams are set up and how the players fill up the minutes for each team. So on the left here, we have the biggest upset of the tournament, arguably of all time. We have UMBC, a number 16 seed, beating Virginia, a number 1 seed, and arguably, you know, the tournament favorite. So you can see UMBC focuses heavily on shooting forwards, while Virginia is all about the guards. Then on the right of this plot is the final teams in the Final Four. You can tell Loyola kind of sticks out. They're the dark horse of getting into the Final Four. So I made 2 models. Both used gradient boosted classification, trained on data from 2014 to 2017 season games, and I tested them on 2018 season games. Now, both of those models had pretty good accuracy. The base model had 66% accuracy over the course of that whole season, while the model with those team composition features had 67%. An improvement, albeit a small one. And then on the right of this, you can see the plot that shows the features and their importances and how they influenced predictiveness in the model, ranked from most important to least important. So in classification, what you're predicting is a probability of an outcome, right? In this case, it is the probability of a team winning versus another. So this is 2 examples for each of the models on how those predictions came out. On the left, again, that big upset, UMBC over Virginia. both of those, I wasn't able to predict that upset. That was so unlikely. But it was interesting to see that the team composition features pushed the prediction in the right direction. And then on the right, we have Kansas over Seton Hall, and that was both models predicted that correctly. But again, the model with the team composition features pushed it in the right direction. So there might be some signal here. I thought that was really cool. So on to the results. So I compared my 2 brackets against 8 worthy opponents, ranging from ESPN's average bracket to sports analysts, and another AI, actually, the Swarmy by a unanimous AI. It's actually pretty interesting. You guys should check it out. But in this,
Yours has a better name.
the Swarmy, the Swarmy's pretty cool. So the model without the team composition features actually performed better, but they both did pretty well. And up until the model with those features predicted Texas Tech to take out Villanova, it obviously wasn't going to get the winner. And then it was done for the rest of the tournament. But it was doing really good up until then. So I have a lot to look forward to, a lot of work to do to update this for next year. But that's where it is for now. Hopefully I'll have a website going on for next season. So again, I'm Sean Costello, and that was the Bracket Buster. My contact information's up here, and this is my tech stack.
Yes. What was the reasoning behind the 5-game rolling average versus another number?
It worked better.
8%.
Yeah.
So I saw that with the team composition features, it was bumping up the probability of the underdog.
Yep.
Do you ever see any games where, including the team composition features, it made the underdog less likely?
Yeah, actually, I definitely did, and also Kansas was not the underdog. Kansas was favored, so this example right here, Seton Hall got less of a chance with those features. But most of the time, it pushed the predictions in the right direction, but not always.
Okay.
That's why I picked Texas Tech over Villanova, and so up until that, it was going really well. I was pretty excited. But
If you just put in Monte Carlo random data,
yeah,
in lieu of the TCF or to populate TCF,
yeah. I haven't done that yet, but that's on the to-do list. I would like to be able to auto-generate multiple brackets and kind of see how randomness can play into the predictiveness. But as of now, it's deterministic. It's the same every time. I type in a team, 2 teams, it tells me who's going to win. So.
Yeah,
Okay.
it's trying to be cool, but like those first 2 slides are like super sexist, and I'm not okay with that.
Yeah, I thought you guys could take a joke, It was all.
But like
Yeah.
the reason that Tony hasn't had her 1-minute Twitter thing is because of stuff like this. So.
Yeah.
Okay, but without that context,
Well, I guess we won't be asking you for a job.
So your TCF classification scheme was doing the K-means clustering on.
Yep.
So I guess as just a clarification, so you took forward, center, or guard as classified by the team, and you did K-means to subclassify?
Yeah, so I didn't just take every player and then just give me 10 groups. I took the centers and then clustered them and found the national subgroupings in those center categories and did that for each of those 3 positions.
Do you think for future iteration it might be worth ignoring what the team program calls each position? Because that might vary a lot from school to school.
Yeah, no, I agree. And there's a lot of examples of that for the NBA, but I've never seen anyone do this for NCAA. And I had a very hard time trying to find those national subgroups that made sense when I didn't separate them in their own individual position labels.
Thank you. How do your results compare to like sports betting odds, and if you were to just use those odds?
If I was to compare just to Vegas, Vegas gets, I think, 73% of the games correct. So I'm not quite to Vegas. So, but Vegas also can't pick a great bracket. So, I thought the whole point of this was to make a bracket. It wasn't to predict, the best, every single game of the season, like I tried to, just to test it. But, that's the goal, is to keep improving it. Maybe even start with Vegas's predictions and then see if I can push it up further in the right direction. I honestly don't have one. I'm a math fan, and
So for the player level clustering, do you factor in relative contribution of each player in any way, or is it just each player is equally contributing to the distribution, like the chart you're showing?
So the features I use to cluster it include like points scored per game, and all those kind of player stats that they have. So their contributions would come in there, minutes played in some of them. So that would be part of it, yeah.
Gotcha. So some of those categories are more influential than others. Is that?
Yeah, that's correct. Some of them really you can just separate the players, and some not so much.
Is it summary level stats for players, or is it like play by play?
It was summary level, yeah. So it's average points per game for this guy, pretty much over the season at this point.
Thanks.
Back to the front. Let's have you guys switch. Last question.
How do you account for or plan to account for injuries?
I don't yet, but hopefully I plan on getting this to be live, updating. So each game it will be like how much of this game was comprised of these team composition. So it's not just the season overall, to where maybe they lose that one player and then the team composition changes, then they might lose that game. So I don't have that built into this yet. So that's part of the auto updating features I want to have for the future.
Thank you, Sean. We have you guys sit tonight. And before we move on, I do want to address this conversation. You might have had a situation like that, and I know exactly what you were feeling, and I did feel it too. So I want to offer this up. I think it would have been even more powerful of a speech or a piece of your talk if it were from your personal point of view and your personal experience, because it kind of seemed like that was what was underlying it. Like, your wife's friends are better at this sometimes. But I do think it's an important thing to recognize, and that she didn't need to create defensiveness or anything like that. Absolutely.
Okay, like, and when you first started, you're making a generalization, there's a speed up with it is some people probably think that's funny, but he definitely was not going to say, those are always good. Sorry if I didn't cross that way. I'm sorry.
Yeah, it wasn't about all that. It was just a recommendation. Yeah. Thank you guys. All right. You ready to follow that up?
My slideshow's ready to go.
It's cold then.
So when I heard we were going to do a sports night, I submitted a proposal that was basically hockey, and lo and behold, it got accepted. So from there, I had to come up with a project. So a friend of mine sent me this paper, which I didn't read, but I did take a screen cap, and this was really just all I needed to go off and see what I could do on my own with this kind of idea. So, hockey teams, professional hockey teams have to travel a lot and see what jet lag does to them. And this is a bigger problem in hockey than it is for baseball, because these teams have to travel quite a lot longer distances, as we have teams in Canada and deep into Canada, not just Toronto. So in order of average distance here, Vancouver Canucks have to travel 1,700 miles on average for their games. That's the longest, and then bottom of the list, Chicago only has to travel 800. The jet lag might play a role into these teams' respective records. So first I scraped the web, so hockeyreference.com. I grabbed every game since 1940. These are game level box top scores, 54,000 games. I worked on constructing a couple of interesting features. This was like 90% of the work in step one. Then I just fed those to some kind of boilerplate machine learning algorithms that scikit-learn, no neural nets. And then I wanted to see if we could use that model to predict something interesting. So the first feature is that obviously teams don't come home after every road game. They go on extended road trips where they travel from point to point. So I had to come up with a way to track a team's road trip and keep track of not just the cumulative number of games that they've traveled on this road trip, but the number of miles since their most recent game. So we're not looking at distance just from home for every single game. This is a distance matrix on the right here between all of the teams in the current NHL. Just for fun, I also threw in a number of jumps in time zones to see if that might weigh in at all. And the other big heavy lift of this project was calculating an ELO score. So this is a scoring method that keeps track of relatively how good each team is at any point in the season. So if a favorite wins, they take small numbers of points from the losing team. If the underdog wins, they take a large number of points from the winning team. So this is the 1940 season. You can see how these teams kind of spread out as the season went on. The good teams rose to the top, bad teams tanked. ELO is actually, it's a name of a guy. I don't know what kind of name that is, but ELO. So the delta ELO between the home team and the away team does factor into the number of goals scored. So it's a pretty linear relationship. So here you see you need a delta ELO of 1,500 to get a 1 goal advantage in the game, or 1 goal favor. And if you're the home team, due to the intersect, you get a half a goal advantage there. So let's take a second and think about what we might expect from this kind of model. Let's go back to this. So we're not going to predict every game perfectly. If we were, I wouldn't be here in Vegas, right? PowerPoint just really wants to go ahead of the slide. So we expect a few percent gain from this kind of travel information, and that's what we see. So if we stick it into just a regular Reddit forest and look at the feature importance, the home and visitor ELO scores are the most important things when you are factoring in travel information. And the distance traveled is actually not too far down the list, at 0.19. Other things like the number of cumulative games on the road trip and the number of rest days didn't really matter quite so much. Surprised me, even if the previous game went to overtime, that didn't matter, because that's usually a lot of extra energy. So on the right here is a rock plot where you can see that our gradient boosted trees algorithm did a little bit better. And so if you look at the distance between the purple and the red line, that's what we gained by adding this distance information. So it's marginally improving our win-loss prediction. But if we go towards a random forest regressor or a gradient boosted regressor, we can look and predict the number of goals that each team is going to score. So on the left here, we have our predicted goal differential and our true goal differential. Colored here is on a log scale, so a perfect prediction is going to be right on that diagonal. On the right, we zoom in a little bit and take the median of each of these bins of predicted goal differential. And you can see that the red line is a little closer to the diagonal than the green line. So adding in the distance information, the travel information, marginally improves our prediction. So what if we took my favorite team, is in the middle of the pack, travel-wise, and we popped them down in Chicago and gave them their travel schedule. You can see on the left the distributions of the distances traveled in the last season between Chicago and Colorado. Chicago, remember, is the one that travels the least. They have a lot of games that are very close by in the Northeast. Our model actually predicts that the record would be exactly the same, but the Avs would just lose their road games by fewer goals. So that's it. Somebody know I can make PowerPoint stop doing this here.
Thank you for not doing a CNN. Where's our questions? You're the hockey people?
Yes. And I'm Caps fan, you can't tell from the hat.
Nobody's perfect.
Did you look into the, what was it 2011, 12, 13 season? Where you might have had a bit of a natural experiment because the Thrashers moved to Winnipeg, but they were still in the same division. So you might have been able to take advantage of the natural effect that like all of a sudden everybody in the same division has a longer travel schedule. Did you look into that at all?
I did not. I did have a lot of fun with the early seasons where there were teams that I've never heard of before. So I had to code in a lot of things like the Golden Seals, the San Francisco Golden Seals in like the 1970s. But no, I didn't actually look at that one. There is a slide in here that has to do with the lockout here.
Yeah.
Okay, well, yeah, we'll just do this here. Any questions about my backup slides? This is my cheap way of getting an extra minute or two. So I looked at the average home ice advantage over time, and also the average number of goals scored per game over time. There's a lot of wiggles in here that I can't explain. Because hockey is an interesting game because they do change the rules quite a bit from year to year. So if you smooth this out, and well, let me. If you smooth this out, I think with a 10-year moving average, you can actually see post-lockout after there were a whole bunch of rule changes, especially related to like goalie pad size, where home ice advantage and number of goals scored both dove precipitously. I don't know why, because the goalie's pads got smaller. You think that would increase scoring. I went through a lot of old rule changes. So the reason I started in 1940 with all this is both that that's the first year they started using Zambonis to resurface the ice between games. It's also the first year they required that referees be from a different city, the home team.
It's the little things. It's the little things.
So it sounds like there's a number of variables that you could try and do correlations with, and that what you want to do is automate the mechanism to go off and say which of those actually have the biggest impact. Because you were making a hypothesis about distance travel, and that's maybe not the most interesting thing.
Well, I mean, the distance travel actually was the strongest thing in the random forest's feature importance. A bunch of my other hypotheses died right there. I thought that the previous game going to overtime would be a bigger deal, or having more rest days would be a bigger deal.
Well, that's so that change. But you take your whole variables visible and then figure out which one's the biggest.
Yeah, Hockey Reference doesn't encode pad size. that's a harder thing to code in.
Do you know if they have a private jet? Versus flying Frontier.
I mean, yeah, they don't fly Frontier. They charter.
I looked it up.
One more question, and then we'll move on.
Do you see any difference after the era of easy jet travel, like 1960s and before that, when travel must have been really horrible?
Yeah, I didn't, because I didn't try. I was going to look up, I kind of ran out of time for a couple of things. I wanted to look at when they started actually flying, when they were just taking buses from city to city. After that, takes a toll. Like, they were also smoking and drinking between periods at that point, so there's a lot of variables you can't.
Was that a positive?
It is for me.
All right, thank you, Steven. All right, this is a good time to grab. Are there really only 2 beers left? No. Oh my goodness! Grab a beer if you want another beer. 20.
2 people.
Awesome. All right. Up next, we have Erin Desmond.
So you all thought you were coming here for sports, and
I don't normally make people get up. I thought the mic was going to take a lot longer. Fool me once, right?
I'm okay. Actually, sure. Thank you.
So while people are getting theirs, we have one more hockey note. If you guys want.
The yellow color.
Related to the genetic streams you mentioned, until 67, there are only 6 teams. They're all kind of clustered in the Northeast. So starting in 68, you've got teams on the West Coast and the Midwest, that sort of thing. So you probably wouldn't really need Jets. You know, they were all mostly traveling by train, so this is my understanding of history. So.
And if you need more hockey fairness, we will come see us who's ready for the Stanley Cup match.
All right, we good? Everybody is here? Everybody's good? Okay, so y'all thought you were coming here for sports, and we're going to do a 180 and talk about the opposite of that, which could be perhaps music. So my name is Erin Desmond. I just finished the data science immersive at Galvanize in Denver, and this is what I did for my capstone project. So the idea for it is pretty simple. I wanted to see, can I use the things I'm learning at Galvanize to write music? Some of the inspiration for this, I have a degree in music and I'm a classically trained pianist, so I used to perform. So while I was at Galvanize, I really wanted to see if I could combine these two different worlds together. I'm sure you've all seen online the computer.
Technical glitch, I'm sorry.
That's okay.
I don't know what it is. I have to look real quick.
It's all the cans opening.
There we go. This should work. Okay, go ahead.
Good? Are we good? Yeah? Okay. Oh, good. Great. Okay. So, like I said, you've probably seen online that there's a lot of text generation from computers. My favorite being the top right here, which has been circulating on the internet for the past few weeks. It's an Antiques Roadshow episode. I won't read it out loud, but it's hysterical, so I recommend that y'all go and Google that later. This is a Twitter bot. It tweets poetry. I think it actually does a pretty decent job. Anyway, so I thought if people are doing this with text, then I can do this with music, right? It's some sort of language, there's context, there's some sort of syntax involved as well, right? So the first problem with this, I had to find a good format. So here on your left, there's staff notation, what music just generally looks like. And on your right is a format that I found called ABC notation, developed by Chris Walshaw. So basically, it's really simple. You take a staff, like a note on the staff, and it translates into ABC, which is just a plain text representation of that. So if you have like a D in staff notation, it's a D in ABC format. It gets a little bit more complicated, so if you have a sharp or a flat, then that will be a different symbol. If you're higher or lower on the keyboard or the range, that also will be a different symbol. But it does a pretty good job translating from staff into ABC. You'll also notice here on the top of the ABC format, there's an introductory body. And this is basically how they index it, where they put the title, what they determine is the meter of the piece. So is it 4/4 times, 6/8 times, so on and so forth. So I found about 1,000 Irish folk tunes that were already in ABC format, which was great. I was also able to translate some Bach, Beethoven, Enya, Backstreet Boys, Michael Jackson into ABC. So I then concatenated that all into one huge text file, and that was my data. So the next thing I had to do was find a model. And I needed a model that would both predict something new and also maintain a lot of context for a long period of time. I discovered the recurrent neural network. We talked about this at Galvanize. And this seemed like a really good idea. So basically what it does, if I give it a sequence or a pattern of notes, it takes that pattern and it predicts based on that pattern what should come next. And then it takes a step forward in time and it does it again and again and again and again. So this seemed like a really great idea. I'm getting both new music based upon context. The problem with RNNs is that over a long period of time, if you have a lot of context, they tend to break down. In theory, they're great, but in practice, they don't do really, really well. And so I needed something that was a little bit more robust. So I'm basically using a variation on a theme called a LSTM, recurrent neural network, or long short-term memory recurrent neural net. So pros and cons, doesn't remember over a long period of time. So here's what an LSTM looks like. So the issue with regular old RNNs is that they update their memory over time using gradient descent. This involves a lot of multiplication by values that correspond to how likely a prediction exists. So you can imagine if you have a lot of predictions that the likelihood is very, very close to zero, when these get multiplied together over a long period of time, basically what happens is it just starts to break down. It starts to not be able to remember anymore, and your model just gets worse and worse. So the LSTM tries to solve this problem. It's basically variation on a theme of a recurrent neural network, but it introduces gates. A lot of the magic happens at the forget gate, and what's essentially happening with the forget gate is that if a value is not super likely to happen, if it's very close to zero, then it will basically forget. So when you move to the next time step, you're not flooding it with a bunch of zeros, and you can maintain context for a long period of time. So using this model, I was able to both get new music that also maintained context for the amount of time that I needed to maintain. So here are my results in the ABC format. So you can see it kind of looks like ABC from what we saw earlier. You can also see that it learned the introductory text, the introductory body, and I'm really excited about that. It also started generating its own titles, which was kind of a surprise to me, but also my favorite thing that the network did. Here are my favorite titles. They mean absolutely nothing. But I thought they were pretty good. And then the ABC that you saw on the previous slide and translated back into that notation looks like this. As a non-musician, I think, wow, that looks like music. That's really, really great. As a musician, it's pretty good. It could be better, but it's not terrible. All right, so I'm going to play the second piece on here, How to Bow a Bow. But before that, here's what I used, some inspirational papers, which I think all of you should go and read. They're great. And yeah, thank you for listening. Oh yeah, you can clap. So I'm going to play this. It's kind of long, so we're going to do questions while this is playing. Or I'll cut it off.
Let's let it play for a little while. I actually listened to it. It changes partway through, but check it out, and then we'll get to questions. It's not hitting as many flat notes as I would during karaoke. So success. Success.
Yeah, whatever.
All right, let's bring some questions in. While we let it play. Rick, you just got dissed.
Super cool. That was really fun. I'm wondering about the idea that sort of the quality of this kind of outcome is a bit more subjective than what we typically think of, right? There's no like classification. So getting to the point. I'm wondering if there's some way to introduce our ability to choose, right? So some way to interact with the algorithm and say, we like this one more than this one, right? Allow that particular way with human interaction.
Are you asking if I did that, or if it's possible?
If it's possible, given your
I want to say yes. I did not do that with this particular project, but I think that if you introduce some kind of classification to this, combine it with some other kind of classification algorithm, So if you listened to a bunch of these pieces, 12 people said we like number 4 the best, and then you say, okay, we want more like that, then yeah, I think that's a really interesting problem.
So to kind of follow up on that a little bit, the generative adversarial networks are exactly that. We're doing technically 2 networks. One is generating a random set, and the other one is classifying it. You tie them together. You have a random generation from one network that the second network is rating, and the actual music into the second network that is rating, and you effectively do exactly that. That's where you can generate artificial faces or artificial scenes or artificial text. And I've not seen it done with music, but you've got basically a tremendous sensory for that right now.
Cool. Yeah, thanks. So it's what did you call that again? The
generative adversarial networks.
Generative adversarial networks. Great.
Cool,
thank you.
Just for a little bit of trivia, you invented those into this huge thing in the neural networks world, and you invented it after an argument in a bar with some crazy kids, and you went home at 2 o'clock in the morning, wrote generative adversarial networks, and got fantastic.
So the moral is go to more bars?
It's probably sufficient to Google and get you thousands of it. So I have 2 questions. One is technical, like how did you decide on the topology of the LSTM?
On the what?
On the topology, like the sort of sizes of the layers.
Yes. So I tried a bunch of different architectures and tweaked a lot of parameters. I decided it based upon what gave me the best results. So I did use an aerometric during training, just to see how well it was actually predicting what should come in a certain place. Like you said, that the actual results are really subjective. So I kind of did a combination of both, and that's how I decided. I watched the error and then I listened.
So my second question is about the subjective part. It's unclear to me how much this translation from music to text actually captures in terms of, musical notation is very expressive in terms of what a musician can do. And maybe it captures the entire thing or not, but it seems to me very possible that the output of this can create music that is not playable by human. Have you seen anything that's not playable by human? Like what I see here is probably playable.
So yeah, I did actually see some. Mostly, sometimes the network predicted notes that did not exist on the staff. So yeah, so it was like really, really low, and I was like, hold on, I don't think that's actually a note, and I checked, and it wasn't. And that's just based on, like you said, the data, the APC format. So yes, I would say there are some that are impossible to play. This note right here, for example, I could play that with 2 hands. Playing with 1 hand would be really, really difficult. So having it in the bass clef is, maybe unnecessary. And you can also see, like here, it's predicting a double bar line, which means the piece is over. And so there are definitely some limitations to the data.
Human playable and human interpretable.
They're very different things, yes.
And we've got one more question behind the pillar. Jump around where you guys.
I really like this. This is fantastic. Thank you. I'm a musician and like stuff, so I love it. But do you think a computer will ever pick up things like staccato or staccato or any of those emotional things you put into the music that you really quantify?
It's a wonderful question. The answer is I don't know. So if you Google, like Google Brain is a branch of Google Research, and they're doing a lot of work with music, and they're using something called Magenta, which I didn't use, but they're getting some really great results. So to answer your question, I honestly have no idea. My intuition is to say probably not in the same way that humans might interpret a piece. But absence of evidence is not evidence of absence. So maybe. And I think people are working on it, and I think it's cool what they're getting.
Awesome. Thank you so much. And so what I always like to end the evening with, aside from another thank you, is just an icebreaker. We're data people, so a lot of us are introverts. I tend to do the introvert-extrovert thing. Not all of us can be happy. Extrovert all the time. So today's is pretty simple and playful, and also because I recently broke my damn phone right before I was going to turn it in. So share how you cracked your phone screen, and darn it, I know you did it at one point in your life, even if it wasn't this current phone. No? Then I want to hear how you guys didn't do it. All right, thank you guys. Have an awesome evening.
It's even not evident yet. So. Yeah.
Good. I have a question favor to ask him. So, I have a buddy, mid-30s. He is in DC, and he's been struggling with work. Trying to get into the UX field, so I was like, at least I have contact with UX. So I'm doing pretty good. Oh yeah? Okay, there we go. Awesome. Yeah, so yeah, I'll send your email. Yeah, sure. Here's his mom. Awesome. It's out there. He's my best guy. I want to do whatever I can. I know he eventually wants to come out. I want to get back here in person like so much. Exactly. Silas. Mr. Tip. Let's go. How you doing? Good. How are you? How's your kid doing?
He's good. Just turned 3. How's your kid doing?
I'm making back to the U.S.
Oh, yeah?
He's trying to, he's talking, we'll know more by end of August, September, but he's trying to get a change going. Yeah. I'd like to be in China or France, but, so he may end up in the U.S. for a while, and then who knows.
Yeah, yeah.
But he's going to make a change. So.
Well, cool. Good for him. How's the job hunt?
Well,
you haven't
to Google a couple of times, and I'm talking to him tomorrow, but
you're sort of leisurely looking, right?
I keep on, well, we've just been on Saw Family, and I saw Ariel perform on Broadway.
Oh, nice. Oh, wow. That's amazing.
And so, well, we had that coming up, and then we had this. So
if you need to talk, go for it.
I never tried to shift.
I'm so
no, I drowned my phone multiple times.
Tell me a story.
Well, one story which is really the most embarrassing is I swim with Boulder Aquatic Masters. Swim group. We do res. We open so you can swim with the res in the morning. And we also put on some races. The only way we can do it, because the city is just insane, is we provide our own guards. And we still have to get out one of the guards. You have to get qualified there. The first race we did, get out and we had some kayaks, and I got one. I had it in before we get out in front of them. I get out, and I don't know what I dropped, and I went and grabbed. I rolled my canoe, my kayak, right from her with my phone. It's like, oh God! Not only did I drown my phone, it's like these people are getting ready to swim 1 mile, 2 miles, or 3 miles, and they're going, that's a guard. He's supposed to help me. And you can't see up right this kayak. So it's still remembered after whatever 7 years. Our whole group was,
My first smartphone, I had it for maybe a month. I keep it in my pocket. When you go to the bathroom.
Yeah, my wife's done that like 4 times.
Oh
Yeah.
my goodness.
Yeah.
My wife did it for the first time in at least a very proper place. Last year we were up there. She did it for food.
Oh.
And she came out. It's like, don't turn it. And my brother's trying to, don't turn it on.
Where's it nice? Yeah. So what is that? Are the front pockets are too small for phones? Is that the problem?
Yeah, and I can't like sit.
Yeah, right.
They're not that deep. But
Dude phones, dude pockets are so much better for that.
I used to have, I was on a design team and we have like all these jokes. We call it Big Pocket.
Big pocket.
Instead of like Big Pharma.
Yeah, that's awesome. Hey, good job, by the way.
Thank
Thanks
you.
for saying something and like addressing it.
I am so glad that you're coming with feedback. Tell me more.
Well, I thought you just did a nice job of like just you weren't overly critical, but you just said like, hey, think about the evaluators. Doing that differently. I thought that was a really good way of not just like because like my concern was we were just gonna move on, and that didn't feel good either. Because it was like, you know what, this is an idea that really important. Like that was a really bad.
That was my biggest concern.
Yeah.
Just what? That weird.
No, that he defensively attacked her. Like I understand the breakdown of communication. I understand that it's
right. Just say
it's
sorry.
a scary place to be
Just
in.
say sorry. Yeah. No. Right. So that was good. I thought that was a really nice. Just like it needed something, and then like it just felt like we was able to just move on.
I was like,
Yeah.
really? Why did I not drink tonight?
Yeah. Yes. Let me have you there. Yeah.
I appreciate it.
Yeah.
It's an impossible situation to handle as far as I'm concerned. In my view, like, okay, when is it valid? When is it not valid? When is it? And so it's hard. To do. I've spoken to a lot of audiences all around the world and trying to figure out how to corral things, let alone on something like that. I was like,
yeah. Right, because it's like you got to keep everybody's night good, right? Like it's all about,
yeah.
And I'm sure it was just a mistake that there's nothing behind it, but the way the questions were raised is, have you ever experienced with your girlfriend? So the question is only addressing men or women that have girlfriends.
Right.
So it's automatically excluding part of the audience. That's sentence structure. That's not sexism. So.
Right.
Yeah, I take that as phrasing.
Yeah.
And it's a good point. Saying it's just a phrasing because that helps confuse it. Because otherwise you have no comment. Because anything can be construed. It's actually one of my cool things about me.
Although Stephen is really fucking funny.
The only positive was that whatever notes I had were gone.
I'm good. Good.
Now this they're gonna hit that road side.
Do you watch? I have one more thing. Do you watch Archer? R2?
Archer.
They've got there's like this
I've
bit.
watched it, but I don't watch
Okay, well, there's this bit that goes through it. It's phrasing.
Phrasing.
You just shout out phrasing. So as soon as somebody says that, you just do. Someone says like, "Oh, I gotta hit the head," and I'm like, "Ah, phrasing." Sexual reference.
Yep.
You gotta check it out. It's funny.
I've seen enough Archer. I like it. I like it.
It's one of those shows you have to get into.
Yeah, I've gone through phases with it.
Archer binge. Archer binge here, there. Yeah.
Hi, my name's Genevieve Schneider.
We added all sorts of other things. One question about valid would be interesting, but also what age and
I'll definitely
all sorts of things.
Congratulations. It's summer. It's a good time to get So that's
was trying to think just yeah, I would think so. In both of those, I could say how it's more interesting to do it if you don't have inside state, you could enjoy it.
With this level,
but I didn't factor in that travel slot because both teams had a travel
To me, that's like, you should travel, figure out a amount of time. Double shot or triple shot last year. Travel inside over to Europe, that there might be a threshold.
So, like a positive show, contributed to the replacement. How much people are stored, and also factored in things like travel and your birthday. They actually have a stronger predictor for them than everything. But they had some number of days, or sorry, number of miles in their third
The other thing I think about, this is sort of tangential to a different angle we were talking about. I've been thinking about Venezuelan players, I don't know how like wondering about things like that. Individual players are like really like still turmoil right now. It's not a good player. Pretty That's a good point. Yeah.
So I play in a beer league. It's the lowest level league, but occasionally we have different nights. So that second night, I'm not playing anywhere near an NHL team.
Yeah, but that's also just a difference in conditioning. Because there was one point in my life where I was actually one of the great things about it, but the problem was also spending 20 hours a week. The best stat I got out of that, I would love to go back. My wife took me back. But I get the news. I'd go down and watch the movies and I'd have a beer. But I like to read the news. But I finished my beer. Yeah. The answer was never. 7.5. So to me, that just proves how mental alcohol is. Because if I know I have to get up, I'm actually early on Saturday. It's just a long ride. It was like, okay, fine, I'm going to work. It's like, this is the stats for relief. Had a perfect track record as far as I know. She'd ask me, what's the weather? I don't know. So he's one.
So what do you, I didn't hear what you were saying.
I didn't say I work at CU. I work in the Bible there. It's a CU
Right now, or? I'm not.
We do like different analysis of
Cool. Sorry, the cell line. Are they
kind of like predominantly married to someone.
So it's not a drug.
No, we're in the drug and not the drug.
Okay.
So I is merely
So that just that side.
Yeah. Yeah, so I use Google Drive as a computer notebook capability now. So you're using Google's computer just in your browser. Great. Yeah. It's called School Laboratory, and it's meant to be able to collaborate with people, so most people can use the same.
Yeah, right.
Like at the same time.
So do they get these? So I'm gonna have to go play with that. Just curiosity. What multi-user features of features did they put in?
I'm not sure. Because that was just the organization.
That was just Spark put in some, Databricks put in some, IBM, we put in some stuff. It's like, oh yeah, these are great. They're cool. And how super awesome. Really gonna, you can do some cool demos. But I remember the Databricks one. Oh yeah, no, give me a break. It's fun.
Yeah, it was really just I didn't want to pay for AWS.
Oh yeah.
And really do it, from my laptop or whatever. They do have GPU instances you can check out. Yeah.
That's like what?
That's the. And then they'll also shut you down after like if you don't take 24 hours.
So like you can't run a process machine at one time.
Yeah. How long? Integrated over hours right now. Yeah.
Wow. What is the your Google account?
Yeah. To your
what was it called?
laboratory.
Yeah. I'll play with that today.
Yeah, right. I don't even
put some notebooks on there and find out what they have.
I guess if we can let everybody have like a petabyte for photos,
yeah, that's very much used. If you just an option, like if you want to find those things that were find those three and regular node or GPU node, and whatever you get, like they're kind of encouraging is you're not quite sure what you're going to get, but there is a command you can run. Choose your notebook and you can install from there, stuff like that.
Do you
It'll be there. Right. That's real. I let it run straight from the data, which would be an hour. I'll put that to a CSV, and there is a way you can import CSV. I didn't have to rerun
Probably not for a while. I gotta focus on teaching my dissertation first.
I was actually thinking about doing something while I try to figure out what I want to do. If I want to do something like, I've got a long-term project that I want to do. First was going to hammer out, and then I was like, okay, well, let's try to figure out which part of it I want to do first.
Yeah, I mean, it'd be a great way to organize your thoughts.
Well, that's part of it. I was like, okay,
Yeah, but no, not for you.
Not on this type of stuff. That's fine. The hard stuff is everything that goes before that. That's where I got busted before. Had a whole design, so it wasn't it's great when it's your own. You can just target. It's work for customer. Some constraints, so it's easy to work around this. There's all sorts of logic to it. When it's your own, you don't learn this.
Do it. I want to see it. Before I do it.
It is. Do you know where it is? It's a big chain. I can do it for 4 years now. It's still
Probably like you feel like you're building your like still
You really don't know. Yeah, right. I read the book away half the protein range. My analysis says I'm going to go in and say, oh yeah, I don't know what
some areas from like a dark zone or just like so by telling what's going on. It's like oh,
because in 30 days, like, you really need time to replicate.
So I wonder too, like I imagine a lot of stuff. Which is you gotta work with what you have.
Yeah, we say every year or so, so this last time we
So you said it's all cardio. So what's the? Like
we also do RNA-seq. Yeah, we have $2 million
So is it fairly streamlined? Like you get like it's like is it a bunch of
yeah, I mean, we do have one last thing to do I also need to talk about state office. And then watching and also
Yeah, it's like a little that's wild. Cool. Closest thing I've worked on related to that, right? I worked on some work on alternative license switches, mapping and miles. There's a lot of different users that here to have e-commerce and and then all a lot of different stacks. Clear different flowers, domestic sunflower. It's pretty recent thing. Cool, because like we are all a huge amount of team there. But we didn't do any breaks. We saw R&D. So all of this was done by our advisor before he came here. In general, we do sometimes we found it wasn't so. And we've only done most of the stuff we have. It seems like they're just not moving. So like, I haven't checked in a while. That sounds super cool. So what we're here oh, is that on that? I heard of that. And it's all about just finding basically